Today we are solving LeetCode problem 11, container with most water. This is a very important two-pointer problem, and the key challenge is understanding why moving a container apart from a pointer always makes sense. Let us understand the problem first. We are given an array called height. Each value represents the height of a vertical line drawn at that index. For example, height equals 1, let me scroll it down. Height equals 1, 8, 6, 2, 5, 4, 8, 3, 7. We need to select any two vertical lines. Together with the x-axis, these two lines form a container. Our task is to find the maximum amount of water that any such container can store. One important condition is that we cannot tilt or slant the container. So we simply need to the area will be the minimum length uh, the minimum length vertical line multiplied by the distance between them. So suppose that we choose one line at index left and another line at index right. The width of the container is become, so calculating the area. So there are two widths of the container will become right minus left. But what will be the height of the water? The water cannot rise above the shorter line because it would overflow from that side. Therefore, the effective height is min of height left, height right. So effective height. So the area of water is, or it can be written like this: right minus left multiplied by min of height left, height right. Now let us look at this example. Height is this. These are the different heights. The maximum container is formed using the line at index 1 whose height is 8 and the line at index 8 whose height is 7. So width equals 8 minus 1, that is equal to 7. So these two are our selected heights, and effective height equals min of 8 7, that is equal to 7. Therefore this area becomes 49. So area equals 7 multiplied by 7, that is 49. Let's discuss the brute force approach. The most direct solution is to try every possible pair of lines. For every index I, we can pair it with every index j after it. For each pair, we calculate the area and update the maximum. So the pseudocode will look like this. We initialize maximum area equal to 0, and for I equal to I from 0 to n minus 1, we run j from I plus 1 to n minus 1. Then we record width equal to j minus I and height equals minimum of height I and height j. Calculate the maximum area, that is maximum area and area, and finally return the maximum area. This solution works, but it checks almost every possible pair. Its time complexity is of O n square. So time is, since the array length can go up to 10 power 5, this approach will be too slow. We need a better solution. So here comes the 2 pointer intuition. We place one pointer at the beginning of the array and another pointer at the end. So left equals 0 and right equals n minus 1. This gives us the maximum possible width initially. We calculate the area formed by these two lines. After that, we need to reduce the width by moving one of the pointer inward. But which pointer should we move? So what we need to do is we need to reduce the width by moving one pointer inward. The question is which pointer should we move? So this is the most important part of the problem. We always move the pointer pointing to the shorter line. This is the answer. Why? Because suppose the left line is shorter than the right line. The area is currently limited by the left line. If we move the right pointer inward, the width decreases. But the effective height cannot increase beyond the shorter left line because that left line is still part of the container. So width is decreasing and height remains the same or it also decreases. So we cannot get a better area. Therefore, moving a taller line cannot give us a better area with the same shorter boundary. Our only chance of finding a larger area is to move the shorter line and search for a taller line. So if height of left is less than height of right, we move left forward. Otherwise, we move right backward. At every step, we calculate the current area and update our answer. So let us write the pseudocode. We initialize left equal to 0, right equals length of height minus 1, the height array that we are receiving, and maximum area equal to 0. Then we run a loop while left is less than right. Width equals right minus left. And container height equals minimum of height left and height right. And current area becomes width into container height. Then we update the maximum area by taking maximum area and current area. Then we check this condition. That is if height of left, that is we are checking which height is shorter. So if height of left is less than height of right, we go inward from the left. Else we go inward from the right. And finally we return the maximum area. Now let us write the Python code. We initialize the left, right and maximum area. Then we start the loop, which is true, which will continue till left is less than right. We capture the width and the continued height. Then we get the current area. Finally, we calculate maximum area, and after that we check which height is shorter and move accordingly. After the loop ends, we return the maximum area. So let me summarize it once again. We begin by placing left at index 0 and right at the last index. We also create a variable to store the maximum area found so far. We continue while the left pointer is before the right pointer. The width is the distance between the two indices. The water level is limited by the shorter line. We calculate the current area, then we update the maximum area. Finally, we move the pointer at the shorter line. After checking all useful combinations, we return the answer. So let us understand it more clearly using this by doing this diagram. We are given this array. Initially, left equal to 0 and right equals 8. And max area equals 0. So what are our heights? So height left equals 1 and height right equals 7. So height left is shorter. So we will move the height left is less than height of right. So we'll move the left pointer. So left becomes 1 and right remains the same. So now height left is equal to 8 and height right remains same 7. So this time right will become equal to 7 and height of right is equal to 3. So again right will move, so right will become equal to 6. Also we are recording the maximum area. So once height left and height right were there, so max area will become the distance between them 7 minus 1. So 6 multiplied by 1 equals 6. So actually it will become max of max 0, max area and the current area. So it is max of 0 comma 6, that is equal to 6. Then once we have moved the left pointer, then we again check and height left was 8. So this time max area becomes max of 6 comma, the distance is now 5 multiplied by 7 and it becomes equal to 35. Okay, so it was not 6 but it was 8. Left, right minus left is 8 and it will become 8. It will become 8 and distance is now 7. So it will become 49. Then right will get updated, height right is equal to 3 So my max area will become max of 49 comma 6 star 3. So that remains as 49. Now right will get updated. Right will become 6. Height of right, that is equal to 8. Then max area will become max of 49 comma. The distance is now 5 and height is the lesser height is 7. 5 into 7 equals 35. So that is lesser than 49, so it will remain as 49. Similarly, the process will keep on continuing and we will get the answer. Now let us try to run the code. So test cases pass. Let us submit it. And we should also discuss the time complexity. So its time complexity will be linear because every element is processed only once. So it is linear. And space complexity is constant because we are not using any other array. So we need to understand why the two-pointer approach is correct. At every step, the area is limited by the shorter of the two lines. Moving a taller line reduces the. So all our test cases pass. Great. So let us understand why the two-pointer approach is correct. At every step, the area is limited by the shorter of the two lines. Moving the taller line reduces the width while keeping the same shorter line. Therefore, it cannot improve the area unless the shorter boundary changes. By moving a shorter line, we discard a boundary that cannot create a better result with any smaller width unless we find a taller replacement. This allows us to safely eliminate unnecessary pairs. So each pointer moves only towards the center. The left can move at most n times, and right can also move at most n times. Therefore, the time complexity is On. So time is On, and we only use a few variables. So the space complexity is O1. Now let us discuss the common mistakes. First mistake is using the taller line as the container height. Remember, water is always limited by the shorter line. The second mistake is calculating the width as right minus left plus 1. The correct width is right minus left. These are positions of vertical lines, not the numbers of array elements between them. The third mistake is moving the taller pointer. We must move the pointer at the shorter line because the shorter line is limiting the current area. The fourth mistake is trying to sort the array. Sorting changes the original indices, and the distance between the lines is essential for calculating the width. So we started with the widest possible container. For every pair of pointers, we calculated area equals width multiplied by minimum height. We updated the maximum area and moved the pointer pointing to the shorter line. This reduced the brute force time complexity from On square to On. The main idea to remember is the shorter line limits the water. So move the shorter line and search for a better boundary. That is the complete solution to LeetCode 11 container with most water.